Hello dear students, welcome to this new video from IGCSE with Optimus. Students, in today's video, we are going to solve third variant of ALevel structured questions paper from May-June 2025 series. Students, before we start with the paper, note that this paper has some challenging questions from topics like diffraction grating, interference and polarization, and potentiometer part from the electricity. So don't go anywhere and watch this video till the end. Let us begin with first question in the paper. You can see first question, part A. It says define velocity. So we can define velocity as displacement per unit time. Question B. In an experiment, two objects A and B are released from the side of a building as shown in figure 1.1. Object A is released from rest at height of 10 meter above the horizontal ground. Object B is released with initial upward velocity of 3 meter per second at height h above the ground. Both objects take the same time to reach the ground and they do not collide with each other. Air resistance is negligible. Calculate height h. So object B's displacement is h, okay, and to calculate object B's displacement h, we have to first find out the total time of object B's journey, and for that we are going to use the displacement given for object A, as both the objects are traveling for the same time as they have said. So S equals to ut plus half gt square, where S will be 10. Since initial velocity of A is 0, ut will be 0 plus half g t square. So t will be under root 2 times 10 over g, that is 9.81. This comes 1.43 seconds. So the total time of journey for object B is 1.43 seconds. Now note that this is the initial position of the object B, and after giving initial vertical velocity, object B is falling downward, okay, and it is covering distance of h downward from its initial position. So this displacement is to be considered as negative, and we are also going to consider g as negative, that is acceleration due to gravity, as negative. So our equation will be negative s equals to ut minus half gt square. So it will be 3 into 1.43 minus half g t square. This gives us answer minus 5.7. So the final value for h is 5.7 meters. Question C. In a second experiment, object B is released from the same height as in B, but with a speed of 6 meter per second at angle 60 degrees to the vertical as shown. Now since the initial speed is at angle 60 degree, we will first find out the initial vertical component of the velocity. So the initial vertical component of velocity is 6 cos 60, which is 3 meter per second. Now note that the initial vertical component of velocity, which is 3 meter per second, is equal to the velocity of object B in the previous experiment. Okay, so the first question, state and explain whether the time taken for object B to reach the ground is less than, same as, or greater than the time taken in the first experiment. So object B has same initial vertical velocity hence it takes same time to reach ground. By considering energy, state and explain whether the speed at which object B reaches the ground is less than, same as, or greater than in the first experiment. Here we have to use conservation of energy. We are giving initial velocity 6 meter per second, which is greater than the previous experiment's initial velocity, which was 3 meter per second. Okay, so we will now be giving greater initial energy to the object, and so its final speed before approaching the ground will also be greater. So we will write greater initial energy given to object as object achieves same height change in gravitational potential energy is same, the remaining energy is converted to kinetic energy, hence greater final speed before object B reaches the ground. Question number 2. A. Define the moment of force about a pivot. So the moment of force is defined as product of force and perpendicular distance from the pivot. Question B. Three objects A, B and C are placed on horizontal beam. The beam is in equilibrium as shown in figure. The beam is uniform and has length of 9 meter. The pivot is at the midpoint of the beam. Object A has mass 90 kg and is at one end of the beam. Object B has mass m and is at distance 3 meter from the pivot. And object C has mass 150 kg and it is at the other end of the beam. Calculate mass m. Now, since the total length of the object is 9 meter, object A is at 4.5 meter from the pivot and object C is also at distance 4.5 meter from the pivot. Now, to calculate m, we have to use principle of moments, which says that total clockwise moment is equal to total anti-clockwise moment. Now, from the forces that they have given, object C's weight will be producing clockwise moment, object B and object A's weights will be producing anti-clockwise moments. So for C, the total clockwise moment that it produces will be 150 multiplied by 9.81 multiplied by 4.5 is equal to object A's mass is 90 kg. So 90 multiplied by 9.81 multiplied by 4.5 plus mass of B is m into 9.81 into its distance from pivot, that is 3. So m is equal to 90 kilogram. So the mass of object B is 90 kilogram. Object A is removed and replaced by a wire fixed to the end of the beam and to the ground as shown. After the change, the beam is again horizontal and is in equilibrium. The positions of B and C are unchanged. The wire has diameter of 1.8 into 10 raised to minus 3 meter and has a strain of 1.2 into 10 raised to minus 3. The wire is not extended beyond its limit of proportionality. calculate the Young's modulus of the wire. Now understand that object A is replaced with this wire and the wire is still able to keep the object in equilibrium, object as in the beam in equilibrium. So wire must experience the same force or apply the same force as that of object A. So force on wire is equal to weight of object A, which is mass of object A multiplied by 9.8. So it is 90 into 9.81, that is 883 Newton. Now for area of wire we will use formula pi r square, that's pi into diameter of the wire divided by 2 and the whole square. This gives us answer 2.5 into 10 raised to minus 6 meter square. Now Young's modulus is equal to stress upon strain. So stress is F into A and multiplied by strain. So F is 883 divided by area of the wire is 2.5 into 10 raised to minus 6 and strain is 1.2 into 10 raised to minus 3. The answer is 2.9 into 10 raised to 11. So the Young's modulus of this wire is 2.9 into 10 raised to 11 Pascal. Object B is now moved to a new position closer to the pivot without passing it. The beam is again horizontal and in equilibrium. State and explain the effect, if any, that this has on the strain in the wire. Now, if we move object B towards the pivot, its perpendicular distance from the pivot would decrease and so the moment produced by B will decrease. Now, to keep the rod in equilibrium, the moment produced by wire A should increase, then only the total will be able to balance the moment produced by object C. So for moment to increase, the force in the wire must increase, and if force in the wire increases, the strain in the wire will also increase. So we can write in answer moment of B decreases so force and strain on wire must increase to balance the moments. Okay, so strain in the wire increases. Next question, question 3. A car of mass 1500 kg is traveling along a straight horizontal road at constant velocity v. The car is subject to total resistive force F as shown in figure. Show that the power P developed by the engine in overcoming the total resistive force is given by equation P is equal to F into V. Now we know that when the object is at constant velocity, forward force which is produced by engine must be equal to the backward force, that is resistive force. Okay, so we know the formula for power, that is work done upon time. Now the work done by engine is given by force into distance or displacement upon time, and we know d by t is velocity, and so we get formula F into V. Question B. The car now moves up a slope at constant speed of 30 meter per second. The slope is at an angle to the horizontal of 6 degrees as shown in figure 3.2. The total resistive force acting on the car is 1600 Newton. Show that the increase in gravitational potential energy of the car in time of 1 second is 46,000 joules. Now, the object is going along a slope like this, okay, which is at angle 6 degrees, and this is the height from the ground, okay. So if the object's velocity is 30 meter per second, then this distance covered by object can be given as speed into time, that is 30 meter. So the distance covered is speed into time, that is 30 into 1, 30 meter, okay. So for change in gravitational potential energy, we can use formula mgh sin theta. The mass of the car is 1500 kilogram, so this is 1500 times 9.81 times 30 sin 6. This comes 44,144, and that is approximately equal to, sorry, my mistake. This calculation comes 46,144, which is approximately 46,000 as they are asking us to prove. Okay. Next, use the information in B1 to determine the power developed by the engine to move the car up the slope. Now understand, the power developed by engine is being used in two forms, you can say. One is to increase the gravitational potential energy of the car, and second is to work against the resistive forces. So the power developed is utilized as work done against friction plus change in gravitational potential energy divided by time. Now, work done against friction will be frictional force, that is 1600 Newton, multiplied by displacement, that is 30 meter, plus the gravitational potential energy, that is 46,000. Divide this by 1 because the time is 1 second we are considering. So this gives us answer 94,000 watt. Next, the car picks up a passenger and then continues up the slope at the same speed as in B. State and explain the effect, if any, that the passenger has on the air resistance on the car. Now, air resistance depends on the speed. Here the speed is constant, hence the air resistance will also remain constant. So we can write speed is constant, hence air resistance is also constant. Next, the power developed by the engine. Now, there are people in the car. As the mass of the car increases, the total mass of the car increases, to maintain the same speed, the engine must produce greater power. So, mass or weight increases, So greater power is needed to maintain same speed. Okay. Now question number 4a, it says state the principle of conservation of momentum. So the principle of conservation of momentum states that the total momentum is always conserved when there is no net external force is applied on the system. So total momentum is always conserved when no external force acts on the system. Question B, an object A of mass 4 kg travels at velocity 6 meter per second to the right on a horizontal frictionless surface. It moves towards a second object B of mass 2 kg that is moving at velocity 3 meter per second in the same direction as A. Object A collides with B. The two objects join and move off together with velocity V. Calculate velocity V. So here we are going to use the equation, that is total momentum before collision is equal to total momentum after collision. Now the total momentum before collision will be mass of A into speed of A plus mass of B into the speed of B before collision. Now after collision both of these objects are sticking together, so their masses will be added and we will write it as 4 plus 2 multiplied by speed. So V will be 5 meter per second. The question 2 says that the percentage of the total kinetic energy, initial kinetic energy of the two objects, that is transferred to the other forms of energy during the collision. Now the energy transferred to the other forms can be calculated by subtracting the final remaining kinetic energy from the initial kinetic energy. So we can first calculate initial kinetic energy. It will be half into mass of A into speed of A square plus half into mass of B into initial speed of B square. This comes 81 joules. Then the remaining kinetic energy will be half into the total mass of two bodies together, that is 6, and their final velocity, which is 5, which comes 75 joule. So initially the objects had 81 joule of total kinetic energy and now they have total kinetic energy of 75. Okay, so the percent of energy converted is 81 minus 75 upon 81 into 100. This comes 7.4%. Okay. Question 5. State why sound waves cannot be polarized. So we cannot polarize sound waves as they are longitudinal and their vibrations are parallel to the direction of wave. Question B. A plane polarized light wave is incident on polarizing filter as shown in figure. So the light over here is polarized light, meaning here the waves are either in vertical plane or horizontal plane or in one single plane. Okay, that we call it as polarized light. The intensity of the light incident on the filter is I naught. The light is incident normally on the filter and the transmission axis of the filter is initially perpendicular to the plane of polarization of light. So understand, if let's say the light waves that are approaching the filter are vertically polarized like this, okay, then initially the angle of polarizing filter is horizontal to the light waves. Okay, so if the initial angle is horizontal and the light which is approaching the filter is perpendicular to it, that is vertical, we are not going to see any light transmitted, okay, because the angle between transmission axis and the plane polarized light is 90 degree. Light can be transmitted only if the angle between the transmission axis and the plane polarized light is 0 degree. Okay, so on figure 5.2, sketch a variation of the intensity I of the transmitted light with the angle of rotation alpha as the filter is rotated through 360 degrees from the initial position. So initially, when the angle between transmission axis of the filter and the light is 90 degree, the light transmitted will be 0. Now when you rotate it by 90 degree, let's say in this direction, the filter will then be vertical like this. If it is vertical, it's going to transfer all the light through it and then the intensity is going to be maximum. Again at 180, the intensity will be minimum. At 270, the transmitted intensity will be maximum, and at 360, it will be minimum. So our wave will look something like this. Okay, next, the amplitude of the incident light wave A naught when the intensity of the wave is I naught. Use Malus law to determine in terms of A naught the amplitude of the transmitted wave when alpha is 20 degrees. Okay, now if we move, see, this is the polarizing angle. Okay, if we move the transmission axis to 20 degrees, okay, let's say this angle is 20 degrees, then the remaining angle is going to be 70 degrees. Okay, so according to Malus law, we can write transmitted intensity is equal to original intensity into cos square theta. Okay, when you rotate the polarizer by 20 degrees, the angle theta is going to be 70 degrees. Okay, note that this is the angle between the transmission axis and the polarizing light. Okay, so we can write IT equals to I naught into cos square 70 so IT is equal to 0.12 I naught. Okay, now we also know one relationship, that intensity is square of amplitude. So we can write IT upon I naught is equal to AT square upon A naught square. Now IT is 0.12 I naught divided by I naught is equal to AT square upon A naught square. So this I naught will get cancelled and AT upon A naught will be equal to under root of 0.12. This comes 0.34. So transmitted amplitude is 0.34 times of the initial amplitude. Let's now go to question number 6. Question 6a says that state what is meant by diffraction. So what is diffraction? It is spreading of the waves at the edge of the gap. So when the waves pass through the gap, they bend at the edges of the gap, and that bending or spreading is called as diffraction. B. Light of wavelength 720 nanometer in vacuum is incident normally on a diffraction grating as shown in figure 6.1. A screen is parallel to the grating. An interference pattern is seen on the screen and the angle between second order maxima is 52 degrees. So from the central maxima, which will be here, this angle is going to be 26 degrees. Okay, and here we have second order maxima. First question, calculate the frequency of the light. So we will use formula V is equal to F lambda. So F will be equal to V upon lambda. Since the light is in vacuum, V will be 3 into 10 raised to 8 divided by lambda will be 720 into 10 raised to minus 9 because it is 720 nanometer. The answer is 4.2 into 10 raised to 14 hertz. Okay. Next question. Calculate the number of lines per unit length in the diffraction grating. So before calculating number of lines per unit length, we will calculate the distance between the lines using formula n lambda is equal to d sine theta. So d will be n lambda upon sine theta. The order of maxima is second, so n will be 2, lambda is 720 nanometer upon sine theta, that is sine 26. The answer we get here is 3.3 into 10 raised to minus 6 meter. Sorry, that's the distance between the lines. Now consider this is a grating sheet, okay, and the total length of the grating sheet is 1 meter. We know the distance between the lines, that is d, okay, so we know the distance between two lines, that is d. So we can write one equation, the total width of the grating sheet is equal to number of lines multiplied by distance between the two lines. So number of lines will be total width divided by distance between the lines. So total width we will take as 1 meter because here the question is asking for per unit length, and the distance between two lines is 3.3 into 10 raised to minus 6. So the final answer we get here is 3.0 into 10 raised to 5. Next, The light in figure 6.1 is now replaced with light of different wavelength lambda. It is observed that the third order maxima of this light are at the same position as the second order maxima of light in figure 6.1. Calculate in nanometer the wavelength lambda. Again, we will use formula n lambda equals to d sine theta. So lambda will be equal to d sine theta divided by n. Now d is 3.3 into 10 raised to minus 6. Lambda is 720, sine theta is sine 26 divided by n, that is 3, because it is third order maxima as they have said. The answer we get here is 4.8 into 10 raised to minus 7. Okay. So in nanometer, it will be 480 nanometer. Next, question number 7. A nichrome resistance wire has length 150 centimeter, cross-sectional area of 2.45 into 10 raised to minus 7 meter square, and resistivity, that is rho, as 1.12 into 10 raised to minus 6 ohms meter. Calculate to 3 SF the resistance of the wire. So we have to write our answer in 3 significant figures. We know the formula for rho, that is RA divided by L. So for R, the equation would be rho into L upon A. So resistivity is 1.12 into 10 raised to minus 6. Length will be in meters, that is 1.5, divided by area, that is 2.45 into 10 raised to minus 7. The answer we get here is 6.857. Okay. So in 3 significant figures, we can write it as 6.86. Question B. The nichrome wire forms part of a potentiometer circuit together with a cell of EMF 1.2 volt and negligible internal resistance, as shown in figure 7.1. The circuit is used to determine the EMF of cell X. The galvanometer is used in null method to find the null point 64 centimeter from the left hand end of the nichrome wire. Explain what is meant by null method. So in null method, what we do is we move the contact, that is over here, until we see the reading on the galvanometer to be 0, and that method is called as null method. So we can write the null method is the one in which reading on galvanometer is 0. Okay. Next question, calculate the EMF of the cell X. Now understand this. The positive terminal of the cell X is connected to this point. Let us call this point as point A. The negative terminal through the galvanometer is connected to this point. We call it as point X. Okay. Since the galvanometer reading is 0, the potential at negative terminal is the same potential at point X, and the potential at positive terminal is the same potential at point A. So the potential difference between points AX will be equal to the potential of cell X. Okay. So we can write the formula here as V1 upon V2 is equal to L1 upon L2. Now we know that the entire length of wire is 150 centimeter, and for this entire length of wire the potential difference would be 1.2 volt. So 150 divided by 64, we can write this on the right hand side. So 1.2 volt divided by V2 is equal to 150 upon 64. Okay, so V2 will be 64 times 1.2 divided by 150. The answer we get here is 0.51 volt. The cell of EMF 1.2 volt is replaced by a new cell with the same EMF but with an internal resistance that is not negligible, meaning the new cell has internal resistance. State and explain the effect, if any, of the internal resistance of the new cell on the position of the null point. Now, understand that if you replace this cell with another cell which has internal resistance, the terminal potential difference in the circuit is going to decrease. Now, as the terminal potential difference decreases, the current increases. The current decreases. Now, that is not going to make any change in the potential difference of the cell X. So, you still have to find out a point which will balance the potential difference of cell X. For this wire, the voltage will be equal to current into resistance. Okay, we are talking about this section of the wire. Okay, it is current into resistance. Now, the current decreases, so for managing the same voltage, resistance must increase. And we know resistance is directly proportional to length, so the length of the wire must increase and the point should be connected little further away from point A, okay, which will increase the resistance. So, you can write due to internal resistance, terminal potential difference decreases and so current decreases. As we know, V is equal to I into R. For balancing same voltage of cell, resistance should increase. For that, length increases, the null point shifts to the right side. Okay. Next, question number 8. An antiparticle equivalent of neutron is called as antineutron. The quarks in the antineutron are the antiparticles of the quarks in neutron. Now we know in neutron we have quarks up, down and down. The elementary charge is E. In table 8.1, state the flavor and the charge of the three antiquarks that comprise the antineutron. So, the flavors of the quark would be up, down and down, and since they are the antiparticles, the charge will be opposite. So, for up it will be negative 2 by 3, for down it will be positive 1 by 3 and positive 1 by 3. Okay. Question B, in beta minus decay, a neutron decays to form a proton. Theory predicts that an antineutron should decay to form an antiproton. A particle and an antiparticle should also be observed. Suggest the names of the particles and the antiparticles. Now to answer this, we will first try to understand what happens in beta minus decay. So, in beta minus decay, we get two particles, that is an electron and antineutrino. Okay, but this theory is about the antiparticles, so we have to write exact opposite of the particles and antiparticles that we get in beta negative decay. So the particle here will be neutrino, which is opposite of antineutrino. And for antiparticle, we will write antiparticle of electron, that is positron. Okay. So students, this sums up our third paper in May-June 2025 series. For the paper that we have just solved, if you have any queries, any doubts, feel free to drop those in the comments and I'll try to answer all of those. Don't forget to share this video with your friends and don't forget to like and subscribe to the channel. Thank you.